Fantastic. Well, thank you all again for sticking around for this next conversation, and what a hard act to follow as well. That was such a brilliant conversation. So I'm really looking forward to taking a deep dive into our next topic. Your panel is called Getting Serious About What It Takes, the Power Play. And as you've just heard, global electricity demand continues to accelerate. AI, electrification, data centers, and demand growth are all hitting the system at the same time. The ambition is high. The capital is moving, but the challenge is building an energy system that can scale fast enough, stay reliable, and stay affordable in the real world. So I'm sure this next conversation will probably follow a lot of similar themes that you've been hearing through the course of the day, but of course, we're going to get today a new perspective on this. So let's start with a reality check for my panel, first of all. We're trying to decarbonize, we're trying to electrify, we're trying to digitize, and we're trying to keep power affordable at the same time. So first of all, what is the biggest challenge that you see right now that is stopping us from moving forward faster? Zoisa, I'll start with you.
I think from the perspective of energy generation in particular, so building all this renewables that we need to meet the demand, it's actually getting energy to consumers quick enough. So it's having all of the enablers and the connecting infrastructure. I think there's a tremendous momentum behind renewables and investment, but just not maybe enough focus on all of the key things we need, like more grid connections, digital grids, all of those things that are going to get power to customers.
Okay, Paulo, frame the challenge for me as well.
Absolutely. So we at Eaton, we have this privileged position to be both sides of the meter. We are a utility technology player, but we are also behind the meter in homes, factories, data centers. So I think it's collaboration is key, and I will frame collaboration in three different areas. One is across the value chain, from natural resources to power generation to power distribution, power transmission and distribution, and integration of major loads. I would say it's also important, we see here under the leadership of the UAE authorities, the connection between different stakeholders, the collaboration is important. And connected to her point, I think we cannot rule out any source of power today. And when in this power addition era, we need to get gas, renewables, and also nuclear to be sustained and implemented in a harmonious way. So the key word for me is collaboration.
Collaboration. Also, excellent point on the energy addition era. Certainly something that Dr. Sultan Al-Jaber also spoke to at ADPEC and also repeated earlier today as well. Miguel, your thoughts?
I think it's an incredibly interesting time. I think we're seeing a huge explosion in demand. But one of the things I don't think you mentioned was also the reliability of the system. And the power system is incredibly robust, resilient in most places, but when you're trying to scale it up and you're seeing this huge growth in demand, it's really important that we are able to do it in a way which doesn't cause, that we keep the lights on. So I give, for example, one of the examples was the Iberia blackout, which happened. You need to make the system more sophisticated as you also scale it up, as you put in more distributed generation and as you put in more load. So I think that's one thing. It's just making sure that we are, let's say, keeping the system sufficiently sophisticated to keep the lights on as you scale up. The second thing is just, which I think is incredibly important, and I'm sure it's been mentioned before, but is that we really need to do a revolution in the way that permitting and licensing is done, because that is what is holding us back, both in terms of connecting new demand, but also in terms of connecting new generation. And so I think that's also something which we need to digitalize, we need to standardize, and we need to simplify these processes so that they can flow a lot faster. It's just taking too long to build infrastructure in most of the developed world, and that's really going to potentially hold us back, whether it's in AI, whether it's in industry or other areas.
Okay, permitting, hold that thought. I want to come back to that. Gregory, what's your take as well? No doubt you're looking at this through a technology and innovation lens.
Yeah. Well, perfect. So it'll be no surprise that our view is that we need to innovate, and we need to innovate with collaboration, with better data. When we looked at the grids about 7 years ago at the Moonshot factory at Google, said, look, this is the largest man-made machine in the world. And it started getting built about 130 years ago. And it was made to basically generate power in one place and ship it to somewhere else. And now we've got EVs, we have energy storage, we have distributed generation, we have flows going back and forth. The grid was never made to accommodate this, much less under the current pressures of data center growth, let alone EVs and electrification. So we started putting our minds around this, and our approach is breakthrough technology to meet global problems at the Moonshot Factory at Google. And so we have been developing a platform that is artificial intelligence for the energy grid. And it is the other side of the coin. There's AI requiring a lot of energy, but then how do we enable AI to make the grid more efficient, to site energy generation more quickly, to bring on data centers more effectively in the places where they're needed most? So we are taking a systems approach to this, leveraging artificial intelligence in service of artificial intelligence to down average the cost of energy and also be able to accelerate this AI transition that virtually every economy is pursuing at the moment.
It's so interesting because it's almost like a double-edged sword here as well, right? You have AI being a demand driver, but at the same time as well, also a solutions enabler. Fair?
Absolutely.
Can I ask you as well, Miguel, with regards to what we're seeing at EDP, you and I were talking earlier about how there's a single data center that's expected to increase demand by around 20%. So how do you prepare for that level of demand, and how do you prepare for the level of demand that we're going to see in the next 5 years as a result of that AI spend?
So as you say, it's a single data center, 1.2 gigawatts, which when all 6 phases are built, will represent 20% of Portugal's consumption demand. So it's, and it's expected to be built over the next 5-6 years. I think just gives you an idea of the scale of the demand that's coming down the pipeline compared to basically the last 10, 20 years of flat demand. First, I think we are fortunate that we have over 75% of our energy is already renewable, hydro, wind, or solar. And we have a good reserve capacity, so we can accommodate a certain amount of that within the current framework. We are increasing our investment in networks by more than 60% over the next 5 years, so making sure that we are also able to absorb some of that demand, because that's just one data center, but we have over 30 gigawatts of requests for a system which typically has 10 gigawatts of sort of peak demand. So there's just a huge amount of power that demand coming down the pipeline. So investment in networks, continued investment in generation, a diversified energy mix, and I think we are fortunate to have a lot of renewables, a lot of solar, a lot of wind, but also hydro with pumped storage, which is fantastic storage, so you don't just need batteries. And I think with a mixture of those things, we can sort of meet that demand. But it is going to require a tremendous amount of investment over the next couple of years.
Paulo, you're nodding there. Do you want to speak to that as well?
No, he touched on a very important topic from the utility standpoint, that there's no sustainability without reliability, right? Without the grid being stable. That's the way we see as well. And from the data center perspective, it's all about speed and technology deployment and dealing with the bottlenecks. So this is the other side of the coin. So when you're exposed to those two areas, what we are doing in responding to this demand is actually looking at disruptive technologies. There's an investment we are doing organically. We are looking at partnerships, because I don't think anybody can tackle this alone. So you need to collaborate more frequently. We are collaborating with companies on the power generation side, collaborating with utilities, with governments, etc. We are talking to the chip manufacturers, but we also invest in capacity, and we invest in local presence, like here in the UAE. So our response to that is you need to innovate not only in technology, but the business model needs to change and evolve. So there's earlier collaboration, co-design, and then implementation at scale. So we are really committed to redefining the status quo of energy distribution and protection.
Zoisa, just on the reliability point as well, what worries you more? Is it a lack of clean energy or a lack of reliable energy?
I wouldn't exactly say it worries me into the future, actually. I think if we take the right approach and we're applying the right mindset, which is very much, let's focus on the consumer and actually designing the right concepts for the consumer. And I think that's exactly what you're doing at Google, for instance, around data centers, and actually saying, look, we can not only be a consumer, a huge consumer of energy, but we have the ability to store and help balance grids. And I think that's a super important thing to remember. So it's less of a concern. I actually think that the beauty of renewables is that you get this amazing peakiness, that if you can use batteries to flatten it off into rectangles, so it's not always a zigzag, you get this ability to consume at super cheap times of day when the wind's blowing or the sun's shining, and the consumer can tap into that. And then, of course, when it's not, and it's not in abundance, we have batteries, or batteries in homes, not just for industry, to be able to do that. And with the advent of AI and technology, we can do enormous things. I mean, at Octopus, we have a virtual power plant now, which is connected with over 500,000 devices in Europe. So that's mainly the German and the UK markets. And that's 2 households. It's the same size as 2 nuclear power plants that can jump on and help balance the grid at any given time. But at the same time, because the consumer signing up to it is saving money on their tariff, storing it, and then allowing us to dispel it through AI, it's enormously quick to build, quicker than generation, quicker than new connections to the grid even. So under 2 years, that was created.
Right. And it's so interesting because I know you were speaking before about this as well. You called the grid fit for the 1930s at one point. So if you could strike just one specific regulation or a bottleneck from the books tomorrow that would perhaps clear that backlog and unlock future capital, what would it be?
To me, it would be finally grid companies releasing data so that you can make really intelligent decisions. So not only from a balancing perspective, but even from starting to plan industrial players in the right places. So put it where it's super windy or it's super sunny. And I think you looked at companies like Masdar, who are showing enormous leadership in this space, where you have places within the UAE that can create 24/7 round-the-clock renewables at 10 cents a kilowatt hour, super cheap. It can also store it, and it's things that are grid saving. It's enabling the cost of renewables to be super low. But to be able to do that, I think grids have to kind of show you where it's easy to build connections, release the data, then match it with places that are super windy or super shiny and super sunny, and then put those large industries over on the top of it. So to me, it's opening up partnership, as you keep saying, and really being open source in the way that we do things.
Gregory, did you want to speak to that as well?
I mean, I would just add, 2 numbers. First of all, there's about 30 to 40% stranded energy in any grid across the world. So efficiency, to my friends at Octopus, is, to point, is so important because that's low-hanging fruit that you can unlock. And in terms of grid reliability, it's something that folks maybe not realize, but a lot of parts of the world, grid reliability is a major issue, a major impediment to economic growth, certainly an impediment to hyperscalers coming into a country if you don't have reliable energy. And most grids, you can't cover more than 30% a year. So typically they're on 3-year cycles, plus or minus, to actually inspect those grids. So one of the things we're doing with Tapestry, our platform technology, is to use satellite information, street views from Google Maps, drones, et cetera, to actually visually inspect and using computer vision to actually detect issues before they occur. So this has been a massive area of focus for us, and bringing grid reliability to much higher levels is absolutely one of the key areas that is low-hanging fruit and can really change the game.
I wanted to unpack the technology conversation in a little more detail, but also just quickly go back to the permitting challenge as well, because I know you flagged that. Miguel, did you want to speak to that, this concern around permitting and what worries you the most?
I think it is one of the major obstacles to actually deploying not just more grids, but also more generation. And I would put together with permitting also local community backlash, because let's also be clear, a lot of the pushback is actually by sometimes local communities that don't want networks to go through their backyard. They don't want solar panels or wind turbines or any generation or hydro or gas or anything. They're just NIMBYs. And so I think that sort of the permitting issue, which is typically a public administration issue, where that we need to sort of simplify and standardize, but also the sort of the community, engaging more the community so that you can actually get stuff done. I think that is really, really, really important. And we need to spend more time educating people, working with the governments, working with the local stakeholders to try and get this infrastructure built. Because I can tell you the number of projects that get stopped, delayed, canceled because of pushback by the local communities is huge. So that is one of the big obstacles I think that we need to address and be very open about it. Just yesterday I was talking to the Minister of Energy in Portugal, and she was saying, like, how can we work together to unlock some of these projects which are being canceled or pushed back? And that's, cuts across the board, across all the different countries and the different regions.
It's such an interesting take on what is seemingly a relatively easy challenge to solve as well. Before we wrap it up, let's focus on technology and some of the solutions out there, because I know this is something that each of you are quite passionate about, whether it's the Google platform or the Octopus platform, everything that you're working on. What is one thing that software or technology or artificial intelligence can actually do right now, today, to address this problem and to ensure that we are in the energy addition era of the future that the world requires? Zoisa, I think I'll start with you.
I think we've got to design products that customers love. I think to this last point, I look to Octopus as a business, and one of the most amazing things that we've done is created people-driven renewables. We've done that through energy tariffs and saying, use wind energy now, you'll get half price off your energy bill. We had 35,000 communities writing on the back saying, can I have a wind turbine because I would like a half price energy bill? You then map the data, you map where you can connect to the grid quickly and easily, you map all the other things that it takes to build a wind farm. We're now deploying something like 6 gigawatts in the UK, and it's people power, it's people driving that, and it's based on the fact that they can get cost savings for living close by in a tech platform. It's actually called Winder, or Tinder for wind, because it matchmakes communities and wind turbines.
I like it. Paolo, over to you.
I think everything that was said here can only happen if the products are connected and are intelligent. So that's our vision. We cannot implement his view, her view, if the products are not connected, intelligent. You can have the human element to manage that. You can have AI to manage that, but the products need to be connected, intelligent. And I will emphasize the point of building bridges. We see both sides of the meter, so just make an example. Within the data centers, we have products that can actually participate in grid services. So it creates a distortion when the AI loads are running, but we have products that can participate. So having that vision of how do I make the permitting easier, how do I make for my customer to approve this in a different way, it will be crucial that we get a little bit ahead of what is expected of us. We cross the line and try to think about the bottlenecks our customers are experiencing. So connected products, collaboration, and reaching across the aisle will be important for us to unlock the value here.
Miguel, how are you thinking about the technology value add?
So I'd say most of the technologies already exist. They just need to be scaled up. I'd say maybe the one that is a little bit earlier or further behind is on the battery side, but we continue to see the costs coming down. That's an incredibly important part. But solar, wind, gas, I mean, most of those technologies are very mature. You just need to scale them up at scale, size. On the network side, again, it's not so much a technology issue. They're sort of issues that you can improve the efficiency, but it's more about getting it built, like about actually getting it done. If I had to sort of wave a magic wand, I'd just invest in the infrastructure to actually manage the licensing and the permitting processes, and get something that is powered by Google or someone else, but that is super efficient and gets, that can be, just be much more agile. A couple of data points, like you go to the different governments or the different public administrations in the countries, ask them, for example, how many processes, how many licenses they have that are being reviewed. They can't tell you. Mm-hmm. We can't imagine, sort of on the company side, like how much underinvestment there is in a lot of these public administrations. And I think that is really the focus. You need to invest more on that side to actually enable us, companies, to be able to then grow further.
Gregory, I'll give you the final word. It seems appropriate, particularly on the conversation around tech and the value add here. Are you concerned or more encouraged about where we are heading in the next 5 years or so? And do you think big tech also gets a bad rap when it comes to your own contributions to energy demand?
Yeah. Well, I think, just quickly, I think in good news, there's a lot that's working towards bringing down the cost curve on energy. There's new chip design, new systems design around data centers. There's more efficiency that we're bringing into the grid. There's more renewable power that's being brought online faster and faster, and it is a question of scaling all those solutions. But to your question, I think there is a bigger aperture here that we should also consider, and why we're all doing what we're doing. And you know, at the end of the day, the tip of the spear of progress is going to be really a function of three things. I think one is the abundance of low-cost energy, which we've of course hit. The second is having high-performing AI models, not just Google, but models that you can trust, models that actually allow you to leverage what you're doing as an individual, as a company, as a country. And the third is a system of ethics and culture that makes sure that this progress is moving in the right direction. And I've been really pleasantly not surprised, but become more and more aware of all the things that I'm seeing here in the UAE, from the higher education initiatives to the focus on renewables and sustainability, and the fact that this is one of the few places in the world that actually has excess electrons today. Makes this really unique, and makes this really the nexus of the next is, it's true. This is a bellwether of what's possible. So I've been really impressed, and I'm excited to be on this journey with my colleagues.
Well, I think that's a really positive way to end our conversation. Ladies and gentlemen, thank you so much for listening in today. And again, please thank my panel for being here.